Let's talk about a few more important basic logical concepts. One concept of central interest to logicians is that of a necessary truth. A sentence is a necessary truth if it is true in all hypothetical scenarios. Logicians are really interested in necessary truth because they don't just want to know what happens to be true or what contingently happens to be the case. They want to know what must be the case. And that means that they are really interested in which sentences are necessarily true. So, for example, philosophers, mathematicians, logicians typically assume that mathematical truths are necessarily true. Why is that? Well, mathematics does not depend on what the world is like. So no matter which way the world is like, a necessary truth is going to be true. And that just means that it is necessarily true. So for example, 2 plus 2 equals 4, simple mathematical truth. It is commonly assumed that this sentence is necessarily true. Now here in this picture, I've represented a necessary truth using the following conventions. I used these circles to represent hypothetical scenarios. And I'm here just simplifying and assuming that there are just 7 hypothetical scenarios. And then I colored all the scenarios in which the sentence 2 plus 2 equals 4 is true. I colored those scenarios in green. And so what this picture represents is that the sentence 2 plus 2 equals 4 is true in all hypothetical scenarios, and that means that it is necessarily true. The opposite of a necessary truth is a necessary falsehood. A sentence is a necessary falsehood if it is false in all hypothetical scenarios. So for example, the sentence 2 plus 2 equals 7 is false, and given that mathematics does not depend on what the world is like, it is false in all hypothetical scenarios. And I've again represented this situation in this picture here by coloring all the hypothetical scenarios in red, representing the fact that 2 plus 2 equals 7 is false in all hypothetical cases. In between necessary truth and necessary falsehoods are contingent sentences. A sentence is contingent if it is true in some, but not in all hypothetical scenarios. So for example, if you think about the sentence, Kamala Harris is the 49th Vice President of the United States, that sentence happens to be true, but it is not necessarily true. It could have turned out false in case Joe Biden had chosen another running mate. So in this picture here, I'm representing the fact that the sentence, Kamala Harris is the 49th Vice President of the United States, the fact that this sentence is contingent, by coloring some of the hypothetical scenarios red and some of the hypothetical scenarios green. Now let's talk more about the relationships between sentences. Two sentences are jointly possible if there's some hypothetical scenario in which they are both true. So for example, think about the two sentences, Joe Biden is the 46th US president and Kamala Harris is the 49th US vice president. Now, there are some hypothetical scenarios in which both of these sentences are false. It wasn't necessary that Joe Biden won the election. There are some hypothetical scenarios in which only the first sentence is true, but the second is false. And there are some hypothetical scenarios in which only the second sentence is true and the first sentence is false. And then there's also the actual world, the way the world in actual fact is, in which both of these sentences are true. So that means that these two sentences are jointly possible. There's a hypothetical scenario in which they are both true. Now, as a side remark, two sentences that are both necessarily true are jointly possible. Since they are both true in all hypothetical scenarios, there must be a hypothetical scenario in which they are both true. And two necessarily false sentences are never jointly possible, given that there's no hypothetical scenario in which they are both true. Now, two sentences are necessarily equivalent if they have the same truth value in all hypothetical scenarios. So for example, suppose we are looking at a picture of Joe Biden and Kamala Harris, and I'm asserting the two sentences: Joe Biden is pictured to the left of Kamala Harris, and Kamala Harris is pictured to the right of Joe Biden. These two sentences are always true together. It's impossible for the first sentence to be true and the second sentence to be false, and vice versa. If the first sentence is true, the second must be true. Now, they don't have to be true. It is possible for both sentences to be false, but when one of them is true, the other one must be true as well. And that is why these two sentences are necessarily equivalent. Now let's reflect on some consequences of these definitions. One important consequence is that arguments with a conclusion that's a necessary truth are always valid. Now, why is that? Well, if the conclusion is always true, that means that there's no possible scenario in which the premises of the argument are true, but the conclusion is false. And that's just the requirement on a valid argument. A valid argument is one which is such that there's no hypothetical scenario in which the premises are true but the conclusion is false. And so if the conclusion is always true, that means the argument must be valid. Furthermore, arguments with a premise that's a necessary falsehood also are always valid. Why is that? Well, if the premises are never all true, that just means that there's no possible scenario in which the premises are true and the conclusion is false. And so that means that the argument must be valid. Now, finally, arguments with necessarily true premises but a contingent conclusion are invalid. Why is that? Well, if the premises are necessarily true, that means that they are true in all possible scenarios. But if the conclusion is contingent, that means that there's at least one scenario in which the conclusion is false. And if we are putting these two facts together, that just entails that there must be a scenario in which the premises are true and the conclusion is false.